Hello students, welcome to AstraDex. Today we are going to see about the gravitation lesson in 11th standard. So before going to this lesson, what the students are thinking is the 11th syllabus is just for mere scoring marks and not for the public examination. But when NEET as well as JEE mains are concerned, it should be very important. For NEET examination and JEE mains examination, the students are missing these 11th standard chapters. So, if you are aiming to crack JEE mains as well as NEET, you have to be well prepared with this 11th standard syllabus also. Okay. Let us move on to the chapter. So when the gravitation is concerned, we have to know about the important topics, concepts involving in it. So in gravitation, we are going to see here about the Kepler's law, Newton's law. Based on these two laws, many of the concepts are explained by using these two laws. Okay, in general, they have given in the chapter itself, we are going to see that Kepler's laws of planetary motion and Newton's universal law of gravitation. These two are used to find the gravity in different planets and the escape speed, orbital speed, and the variation of gravity, that is acceleration due to gravity on the surface of Earth, about latitude, altitude, as well as about the rotation. So these things we are going to discuss in this chapter. Okay. See here, when the gravitation is concerned, first the introduction. In introduction, they have given that in introduction, we can see that introduction to gravitation. See on the screen, the gravitation. Everyday examples are given. So first, Newton, he noticed that when the object is falling down on the Earth's surface, when he sat under an apple tree and thinking of some concepts, that time an apple fall down on his head. These things you already know in the lower classes itself. This history and this story you might have learned in the lower classes itself. So based on that incident, he came to a conclusion that all the particles are attracted towards the Earth. Why this attraction is happening and what is behind it? So these things he analyzed and gave the proper explanation, and that we are going to see here. And before that, Galileo suggested that all the objects are falling down under the gravitational force regardless of its mass or size. And this thing he able to explain by using a feather and a coin from the leaning tower of the Pisa. So these might have been studied in the lower classes itself, and the explanations are given in the lower classes itself why it is causing, and based on these things we are going to see about the next concepts. When we consider about the whole universe, all the objects in the universe are attracted each other. The gravitation force is attraction only, there is no repulsion at all. But when we compare to other forces like magnetic forces or electrostatic forces, they can be attractive or repulsive. But here the gravitation force is only attractive force, and moreover it is a large range force. When we compare the natural forces, the large range force is the gravitational force. It is applicable to a long distance. Okay. Let us see here the concepts based on concept based on the gravitation. First of all, Ptolemy, he suggested that geocentric model. What is geocentric model? It is nothing but keeping the earth as center, all the planets including sun is revolving in circular orbit. See here, in this place it is given, see at this model, earth as a center, earth at the center, all the bodies, see in this diagram itself, earth is at center and all the celestial bodies are revolving around the earth in circular orbit. See here, sun is also moving. See in this place, the sun is also revolving around the earth. This is the geocentric model, and it was given by Ptolemy, a Polish astronomer. So after that, Nicholas Copernicus, he gave the next model, that is called heliocentric model. Helio is nothing but helium. Sun is made up of hot ball of hydrogen and helium. So it is called as heliocentric model. So in this, so you can see in this diagram itself, see the sun is at center and all the planets are revolving in circular orbit, including earth. See here in this place, earth is there. So all the planets are revolving around the sun in circular orbit. So this is called heliocentric theory or heliocentric model. These two theories are first suggested by these two scientists. They are astronomers, Ptolemy and then Nicholas Copernicus. See here the comparison is given in this diagram. Look at this diagram. This is the comparison of heliocentric and geocentric model. So each planet having its own moon or natural satellites. They are called as natural satellites. Moon is called as natural satellites. So in this place you can see in this diagram that some planets are having moon and they are revolving around that particular planet in circular orbit. So this is the difference between the geocentric model and heliocentric model. So after that, many Greek peoples, they are very much interested in seeing the universe. So when they look at the sky, they found that there are many stars. In that stars, some of them are very bright. Why these stars are very bright? And there are some group of stars. And these kinds of stars was analyzed by Tycho Brahe. He used the astronomical telescope and find the stars and group of stars, and this group of stars is called as the zodiac symbols. So there are some group of stars which are available on the universe. So when we compare with the north and south pole, there are some polar stars available in that places. So next, he observed, the Tycho Brahe observed the moving particles. They are called as shooting star. They are called as shooting star. And most important and the one which is revolving around the sun across all the planets perpendicular to the planet. When we can see these orbits, see all the planets are revolving in same plane orbits, but that shooting star, or it is otherwise called as the meteors. It is also called as meteors. Meteors are nothing but the shooting star which is coming under the action of gravity. Because of the action of gravity, some stones enter into the Earth's surface and it glows because of the hydrogen present in that and due to the friction of air. And that's why it is called as shooting star and it is called meteors. After falling on the surface of the Earth, it is called meteorites. When it falls on the surface of Earth, totally the gas particles are totally burnt out. So the stone only striking on the surface. when we look at this moon surface, there are so many meteorites are hitting on the surface of moon, and the craters are developed in that place. Craters is nothing but the hollow place where the stone is falling on the surface. So these things also are noticed by the astronomers. Next, we are going to see about the Kepler's law of planetary motion. This is very important part, and mostly 2 mark questions or 3 mark questions can be asked from this part. So these things are very essential for exam point of view. So when we consider about these laws, first it is classified into 3 categories. Kepler's law of planetary motion is of 3 laws. First law, second law and third law. First law is called as law of orbits, and second one the law of area, and third one law of time period. So look at this diagram. This Kepler's first law states that keeping sun as one of the foci. See here, sun is at one of the foci. All the planets are revolving around the sun in elliptical orbit. For ellipse, there are 2 centers, and that 2 center we call it as foci. The 2 centers we call it as foci. Keeping sun as one of the foci. All the planets, see here, all the planets are revolving in elliptical orbit like this. So when it is revolving in elliptical orbit, the long axis is called major axis, and the short axis, see, when we draw the axis perpendicular, it is called as minor axis. So this is called as minor, so smaller one. So it is called as minor axis. Half of the part where they are intersecting each other, at this point they are intersecting each other, and these 2 points, this point is the almost the center of the ellipse. We cannot call it as directly center, they are meeting. That is the intersecting point of major axis and minor axis. So from that point, one half is called as semi-major axis, that is taken as A, and another one part in the vertical side is taken as semi-minor axis, it is taken as B. So whenever the planet is revolving around the sun, in some place it is coming very close to the sun. See here, this is the closest place where the planet is reaching near the sun, and that position we call it as perihelion position. See here, this is called as perihelion position, and it is also called as perigee, perihelion position, or it is called as perigee position. And when the planet is placed, when it is very far from the sun, say when it is very far from the sun, it is called as aphelion position. See in this place, it is given as the aphelion position, or that is called as apogee. Perigee position, and another one is apogee position. This is called aphelion, farthest position from the sun. And these semi-major and semi-minor axes are involved in calculations so that we can find the average distance. That average distance we are going to use in the third law. So that's all about the first law. So these laws are very important, and it is oftenly asked in examinations. So as for the examination point of view, it is very much important. So when we pass on to the second law, it is called as law of areas. So when the law of area is considered, see, look at this diagram. When the planets are very close to the sun, so this is the left position. See here, this position, at this place the planet is very close to the sun. So in this place, the area swept by the planet, the area swept by the planet for some interval of time. Say here it is taken as T3 and T4. The time gap between T3 and T4 is equal to the time gap between the other end, say T1 and T2. See in this diagram, it is given as the time taken when the planet is traversing from T1 to T2. That time is equal to the another end, It is moving from T3 to T4. So both the times are same. But see, look at the distance traveled. The distance traveled is different. So when we consider about the position T1 and T2, the time taken is same, but the distance traveled is smaller than the other side. So it indicates that the planet, when it is far away from the sun, that is in the perigee position, it moves very slow. And when it is nearing the sun, it moves very fast. That is some difference in velocity of the planet. It is not causing very much amount of difference. It is causing somewhat some differences in the velocity when it is moving farther place and also when it is moving in the nearest place. So because of these, if we find the area traversed by the two positions of the same planet, the area coverage is same. That's why we can say that they are sweeps equal areas in equal interval of time. See, the point is given here. The planet to the sun sweeps equal areas in equal interval of time. In equal interval of time, they sweeps the equal area. But for making this, it has to travel with different velocities. So when the planet is at farthest place, it is moving slowly. When it is at the nearest place, it is moving somewhat faster. That is the point that we have to keep it in mind for this second law. Okay, but what it is stated here, related to conservation of angular momentum. It is related to conservation of angular momentum. Angular momentum is conserved at this place. In second law, the angular momentum is conserved. Next, the third one, that is Kepler's third law. Third law is called as law of periods. So when law of periods is concerned, the square of orbital period, look at this place, the square of orbital period is proportional to the cube of semi-major axis. So here it is given that T square is proportional to R cube, where T is the time period. Capital T is the time period. Time period is nothing but the total time taken for one full complete rotation is called a time period. And that time period, square of this time period, is directly proportional to cube of semi-major axis. So in some places they have instructed that it is the average distance between sun and planet. Sun and planet, the average distance represents that the average of semi-major and semi-minor axis. So in some books they are referred like that. So as per the formula is concerned, T square by R cube equal to constant. T square by R cube is equal to constant because T square proportional to R cube. Here we have to introduce a constant. In this place we have to introduce a constant. So that is T square is equal to a constant into R cube. So when we bring this R cube to other side, this becomes T square by R cube. T square by R cube. So it is taken as a constant, and this constant is same, almost same for all the planets. So it is nearing, somewhat it is nearing, say 3 or 2.9, 3.1 like that. So it is nearing 3. The constant value is nearing 3. It is approximately equal to 3 for most of the planets. See here example, some planets is compared here. Earth, Mars and Jupiter. When we consider about the planets in the solar system, the planets which are in front of the Earth surface, the Earth, that is taken as short distance planet, and after Earth they are called as long distance planets. So for that they have given the period. For Earth it is taken as which is equal to 1 year. The planets Mercury is less than 1 year, Mars 1.88 and Jupiter 11.86 years. So the last planet is having more time period. It is having more time period. That is, it is moving with a longer semi-major and semi-minor axis. So comparing these all planets, they have given the graphical structure. When we draw the graph by taking r cube and t square along y-axis and r cube along x-axis, we can see that it is a straight line. The graph is a straight line graph with a positive slope. If you take the positive slope here, so it will give slope is nothing but y by x, y-axis by x-axis. So see here, y-axis, what is there in y-axis? T square. So t square by r cube. If you take the slope at any place on this straight line, the division value of t square by r cube, the ratio of t square by r cube is always constant. So these things we can see at this point. Sometimes they will ask one more questions related to this third law by giving the constant value as well as t. You have to find the average distance r. Or in some of the problems, numericals, they have given t value, time period, and the average distance is given. You have to calculate the constant value. Like that, sometimes one more questions can be asked in multiple choice MCQ type of questions. Okay, next we are going to next topic, that is universal law of gravitation given by Newton. So Kepler's law, that is an important question. Likewise, Newton's universal law of gravitation is another important question. So Newton analyzed that all the particles in the universe, they are attracted by each other, and that attractive force is directly proportional to product of the two objects, the product of the mass of the two objects, and it is always inversely proportional to square of the distance between them. So it is also called as inverse square law. When we consider about the distance and force, the distance is always the force. When we compare the force and distance, the square of the distance is always inversely proportional to the force. So that's why we call it as inverse square law. So look at this diagram. There are two objects. There are two objects of mass m1 and m2. These two objects are kept at a distance of r. The distance of separation is r and mass is given as m1 and m2. So the force of attraction. See, in all the places, whatever may be the forces are in opposite directions. See, one is towards left and another is towards the right. So it is always in opposite direction. That total amount of force can be calculated by using this universal law of gravitation. F is proportional to, first you have to write like this, F is proportional to, as per the law, it is proportional to product of two masses and inversely proportional to square of the distance. So we are always using some constant instead of this proportionality symbol, and in this place Newton used the universal law of gravitation constant capital G. That is the constant involved here, G m1 m2 by r square, where G is the universal gravitation constant, which value is 6.67 into 10 power minus 11. That is its value. So in most time the problems can be asked from this part. It may be in 2 mark or 1 mark questions or MCQ type of questions. The given data, mostly they have given mass m1 and m2. Two objects having mass 2 kg and 5 kg are separated by say 15 meter. So distance is given, m1 and m2, all the values are given in that question. So we have to calculate the force. So for calculating the force, G value, it's a constant that you have to keep it in your mind. In most of the laws, the constant that we have to keep it in our mind. sometimes that constant value is not given in the question. That time we have to use our memory values in that place. You should not confuse with small g. Small g is acceleration due to gravity, it is 9.8. Capital G, it is a constant called universal law of gravitation, its value is 6.67. So you should not be confused with the same symbols. Okay. After that, if you substitute all the values, you will get the force. So sometimes they will give that whether the force is attractive or repulsive. So in this place it is always attractive force. There is no repulsion is there between the masses. All the celestial bodies in universe are attracted by the law of Newton's law of gravitation. Okay, students. So today we saw about Kepler's law of planetary motion and Newton's universal law of gravitation. These two laws are very important for the exam point of view. So before that we saw about the heliocentric theory, geocentric theory. Sometimes it may also be asked in MCQ type of questions. What are state about heliocentric theory or geocentric theory? Who put forward geocentric theory? Who put forward the heliocentric theory? Likewise, sometimes the question may be asked. And about the meteors, what by using the astronomical telescope Tycho Brahe, he found many stars and named. Out of that, many brightest stars are present at the center of universe. In solar system, the solar system is at one corner. It is 1/3 distance from the center of the universe. So sun is also a star, but sun is the star which is very close to the earth. So it appears very big. But there are more stars which are very brilliant, which are very high distance from the sun. But it is lying in the center of universe. That's why we cannot able to see that with the telescopes. Okay. I hope that you might have cleared about these two laws about the gravitation chapter. Likewise, all the chapters and concepts are very simple. So if you go through it regularly and you have to recall it oftenly, then you can keep all the points in your mind. Okay, let us see with the next chapter in future classes. Thank you, bye.